Good morning, ladies and gentlemen. In my last class, we have seen about the shape of the earth and the lines drawn on the surface of the earth, like the great circle, the small circle, the rhumb line, the latitude, the longitude, etc. Today, we will learn more about the lines drawn onto the earth and their significance. The first thing what we come into our mind is that whenever I want to go from one place to the another place, so I need to define the direction in which we go. In the layman term, it is enough that come towards the east, go towards the south, like this. Okay, we all have seen in my last class that what is east-west. Okay, when we talk about the east, west, north and the south, these directions are known as the cardinal direction, whereas the direction which is in between the north and the east is known as the northeast, and the direction which is in between the south and the east is known as the southeast. Similarly, we also know the southwest and the northwest, but these are a classification which is very, very broad. But when we have to talk about in terms of the aviation, they have to be measured in terms of degrees, minutes and seconds. But mostly, as far as going from one place to another place is concerned, we use mostly the degrees. And when we talk about the degrees, we have to define a datum from where it measures. So the datum while measuring the direction is the north. So now we can assume that the north is 0, 0, 0. Or all of us know that there are 360 degrees in a circle. So if I started measuring the degrees starting from north, it will be 0, 0, 0, 0, 0, 4, 5, 0, 9, 0, 135, 180, 225, 270, 315 and 360. So therefore, the north direction can also be defined as 0, 0, 0 or in some case 360. But mostly 360 is what is used in aviation. So likewise, when we talk about the direction, so I can tell that if you want to go towards the northeast direction, so you will have to go towards 045 degrees removed from the north. Similarly, if you want to go towards the east, you will say that you will go 090 degrees from the north. So this is how we define the direction in aviation. So this direction, there are different types of measuring this direction. So when we talk about this direction, since the reference or the datum is the north, we need to define the different types of north first. So when I talk about the north, what we have said is the direction onto which the earth is rotating, or the earth is rotating is the east. So the poles are the extremities through which the earth is rotating. So these poles, when we talk about the geographical pole or the true geographical pole through which the earth is rotating, that pole is known as the north and the south. So if I follow a particular meridian, as what we have learned earlier in my class, that this is a particular meridian. If I continue going on to this meridian, finally I will reach the north pole. When I go towards the south, I will reach the south pole. This particular direction is defined as the true north or a geographical north. The next type of north is defined as the magnetic north. Let us assume that this telephone is a magnet and it has been suspended freely without any resistance. As we all know that the earth has got its own magnetic field, so therefore the earth's magnetic field will have its own north pole or the south pole. So all of us know that the south pole of a magnet will attract towards the north pole, and the north pole of the magnet will go towards the south pole. So what happens is, if I suspend this magnet freely without any interference or without any resistance, this particular magnet will try to align itself towards the north-south direction. Okay, the direction this magnet points, the blue part, okay, of the south pole, okay, the red part is the north pole, okay, the direction onto which this magnet points, that direction is known as the magnetic north or the magnetic south. Okay, understood? So if I have a magnet, okay, and it is suspended freely without any resistance, this will try to align with the Earth's magnetic field, and the direction onto which this particular magnet aligns onto the Earth's magnetic field is north and the south. So this particular north and the south is defined as the magnetic north. Sometimes it may be different from the true north, or it may be same as the true north. Now, if I keep this particular magnet inside an aircraft, so as all of us know that the aircraft has so many systems which are electrically charged. So, and all of us know that electromagnetic effect, okay, on magnetism. Okay, the components of these, okay, will have its own magnetic component, and this magnetic component which are there inside the aircraft will try to disturb the direction in which this particular needle is pointing. Understood? So if I place this magnet inside the aircraft, because of the magnetic field which are developed inside the aircraft, because of the electrical circuits in the aircraft, this particular magnet which was to point towards the north, that is the magnetic north, may be deviated a little, okay, from that magnetic north. The direction onto which this magnet which is inside the aircraft points is known as the compass north. So therefore we have got three types of north. That is the one which is the true or geographic north, wherein the parallels go and join the north pole or the south pole, and the next one, a freely suspended magnet points, okay, that is the magnetic north. The third one, which is the compass north, which has been the magnetic north influenced by the electrical system or the magnetic system inside the aircraft. That particular direction is known as the compass north. Okay, after having understood this particular north, we need to define the direction onto which the aircraft is going. So whenever I fly an aircraft, the aircraft has to point, the nose of the aircraft has to point towards a particular direction. Okay, the fore and aft axis, if we assume that this is an aircraft and this is the nose and this is the tail, this particular axis is known as the fore and aft axis of the aircraft. The direction onto this, the fore and aft axis of the aircraft is pointing, is known as the heading. Okay, so if I talk about the heading, okay, if the aircraft is pointing towards the north, this is the aircraft, it is pointing towards the north, we say that the heading of the aircraft is 360. Similarly, if I turn this and if the aircraft has started pointing towards the northeast direction, we will call that the aircraft's heading is 045. So since we have got different types of north, we will have to try to bring in some relation between these north. So now when we talk about these north, the variation, there is a term which is known as the variation. The variation, okay, is nothing but the angular difference between the true north and the magnetic north. If we assume that the line which is shown on the red line, okay, is the true north, and the line which is in green and the blue are the magnetic north. The true north is generally denoted by this shape, which is, you can call it the diamond shape, and the magnetic north is generally denoted by a triangle as shown here. So the angular difference, this magnetic north and the true north, is known as the variation. Okay, so it can be either way, like the magnetic north can be east of the true north or west of the true north. So if the magnetic variation is east of the true north, so we will call it as a variation east. And if the magnetic variation is, if the magnetic north is onto the west of the true north, then the difference between the true north and the magnetic north, which we call it as a variation, will be denoted as a variation west variation. So now if we have a look at this diagram and the table below, and if I started measuring that, this is the path in which the aircraft is going. So in which direction this aircraft is going? So I have to start measuring from the true north or from the magnetic north. So this particular direction is the angular difference from the true north, which is shown in the red line here. If I measure this degrees removed from that true north, okay, this is, let us say, 120 degrees. So this particular direction in which the aircraft is going will be in a heading of 120. Okay, mind you that whenever we say or whenever we talk about the direction in aviation, it is never 120 or in never 110. It is 120 separately, or 360 or 180. So here the measure of these degrees from the true north, which is depicted by the red line, is 120 degrees. So the aircraft heading is 120. Let us say that, let us assume that the magnetic north lies towards the east of the true north. So what will we say? That the variation is east. So if I started measuring the direction or the heading, okay, from this magnetic north, then the line which is showing in the green will be slightly lesser than that line which is shown in the red color. So therefore, by how much? By 10 degrees. So the magnetic heading of this aircraft is 110. Similarly, if I assume that the magnetic north lies west of the true north, then I'll have to start measuring it from this place. So if I start measuring, okay, the blue line shows that, okay, this particular angle is the magnetic heading of the aircraft. So in this case, when the variation is 10 degrees west, then it will be 120 plus 10 degrees, which will be 130. This particular thing which I have talked about is been summarized here in the table. So when the variation is east, my direction, true direction, was 120, and the variation which is 10 degrees east, so therefore the measure has been less, so 110. Similarly, for the variation which is west, the direction will be 130. So the mnemonics is that, okay, if the variation is east, the magnetic direction will be least. Similarly, if the variation is west, the magnetic direction is the best. So best means add magnetic direction 120 plus 130, add, and the least means 120 minus 10 degrees 110. But this is the mnemonics. But however, whenever you have any kind of a doubt, I suggest that you draw this picture of the true north and try to draw the magnetic north and start measuring the degrees from there. This will be, you will never go wrong if you follow this. Similarly, we have talked about the compass north. So if I talk about the compass north, there can be a difference between the compass north and the magnetic north. So this particular deviation, that is the angular difference between the magnetic north and the compass north, is known as the deviation. Similarly, like what we have defined in the variation, this deviation can also be annotated either east or west, depending upon whether this compass north lies east of the magnetic north or west of the magnetic north. So this particular table is similar to the table what we have discussed. Okay, if my magnetic heading is, let us say, 120, and if the deviation is which is depicted by the yellow line here and the yellow arc here, so it will be lesser than 120. So therefore, by how much? By that deviation, that is 10 degree east. So therefore, my compass heading will be 110. Likewise, if my deviation is west, 10 degree west, I'll have to start measuring from here, okay, which is depicted by the white line here, okay. So my magnetic node was 120, which is depicted by this green line. So now in this case, the compass node will be 120 plus this deviation, that is 10 degree west. So therefore, it will be 130. The same mnemonics can also be applied here. Deviation is east, then compass will be least. Deviation is west, the compass is best. However, as I told you earlier, that instead of using this mnemonics, if you can draw this diagram, then you will never ever go wrong. Now, let us put all of them together. So we have defined the true north, we have defined the magnetic north, and then we have defined the compass north. So let us put all of them, or place all of them together. So now if I represent the true north with this red, okay, the diamond here and a triangle here, the compass north is represented by this sign here, okay, that is the semicircle, or sometimes you may find it as a letter C written here. So now if the aircraft is flying towards this direction, I can measure the direction in which the aircraft is going in 3 different ways. If I measure from the true north, it will be the red arc here, for which I assume that, or I will say that it is 120 degrees. So we will say that the heading of the aircraft is 120. Let us assume that the variation of the aircraft is 10 degree west. That means to say that the magnetic node has to lie west of the true north. In this case, 10 degrees west. So now I'll have to start measuring the direction from this yellow line here. Okay, on this yellow arc, this will be 120 degrees plus the amount of variation, that is 10 degrees west. So it will be 130 degrees. Magnetic direction or magnetic heading is 130. Now further, if we add the deviation, and if we assume that the deviation is 10 degrees west, I'll have to start measuring from this compass north in order to find out the compass heading. So it will be obviously more than both of them. So 130 plus 10 degrees west, 140. So I will refer that, or I will say that the compass heading is 140. Understood? Similarly, I will show you a diagram of east deviation and the east variation. If the variation is east, okay, I know that the magnetic node has to lie east of the true north by 10 degrees. So therefore, when I measure this, okay, it will be 120 minus 10, so 110. Likewise, if I have to measure or I have to find out the compass node, then the compass node is here, which is represented in the white line, which will be further decreased by 10 degrees. So the compass node will be 100. So when we talk about the variation, there are many lines which can be drawn on the surface of the earth, where if we join all the places where the variation, okay, is same, that particular line on the surface of the, let us assume that this is the surface of the earth, and that this particular line which my hand is tracing is the line which has got the same variation. This particular line will be known as, or it is known as, the isogonals. And in these isogonals, we also may have an isogonal wherein the variation is 0. That particular isogonal is known as the agonic lines. Now, further, if we have to move on about the lines which are drawn onto the surface of the earth and the direction, okay, we will talk now about the direction. Okay, now, if I assume that this is point alpha, which is at north 050 degrees 10 minutes and 15 seconds, and east 072 30 minutes and 45. And if we assume this as a Greenwich meridian, okay, so this is a Greenwich meridian, okay, so 10 20 30 40, so let's assume that this is 72 degrees, and this is 72 degrees. So this particular meridian is 72 degrees 30 minutes and 45 second meridian. So this is particular meridian, okay, that particular point lies in this meridian. And if we talk about the latitude, okay, the degrees from the equator to that place, and let's assume that this is 50 degrees 10 minutes and 15 seconds. So this particular point alpha can be identified by north 50 degrees 10 minutes and 15 seconds, and the east 072 3045 seconds. Similarly, I can have another point on the same latitude, okay, same latitude 50 10 and 15, and the east is now 100 degrees 30 minutes and 45 seconds. So they lie on the same parallel of latitude, same parallel of latitude. So if I have to proceed from point alpha to point Bravo, okay, since as we have discussed earlier that all the parallels of latitude are drawn easterly westerly direction, isn't it? So if I say relate that if I'm going towards the east, I'm going towards 090 direction, and if I have to go from point B to point alpha, then I will say that I'm going towards 270 direction. Similarly, I can have another point Charlie on the equator, okay, equator is, okay, 000 and the 072, this is the same particular meridian. So if I have to go from point Charlie to point alpha, okay, it will be approximately, okay, 055, okay, and if I have to go back from this, it will be approximately this. Why I said approximately is there is a reason. When we talk about the actual measure of the direction, it is, we are talking about the sphere, okay. So the plane trigonometry does not apply, okay. If I draw a right angle triangle, I can measure straight away the degrees from perpendicular axis or the horizontal axis. But however, in a sphere, measuring the degree is slightly different than the plane trigonometry, which is out of your syllabus, for which you have to use something known as a spherical trigonometry. So now we will talk about something known as a change of the latitude, or in short, it is also known as the CHLAT, 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 or difference in long, the difference in lat, the lat. Okay, it is nothing but the, if I am on the same meridian, the difference or the change of latitude from this place to this place, which will be the difference in the latitude numbers, okay, this particular change in the latitude along a particular meridian, I repeat, along the particular meridian, is known as the CHLAT. So when I talk about this particular meridian, okay, this particular meridian, that is 100 degrees 30 minutes and 45, and this particular point, as it lies on the equator, it will be north 0000, okay, and in the same point, okay, which is 100 30 and 45, and at 50 degrees north, the change in the latitude is 50 minus 0. So there is a change of latitude of 50 degrees. This 50 degrees is known as the CHLAT. And depending upon the direction of change, it will be represented by north or south. So if I say that the change in the latitude from alpha to Bravo, since it is change is taking place in the northward direction, it will be known as the CHLAT north, 50 degrees north. And if I have to say conversely, the change in longitude from Bravo to alpha, it is 50 south. So now, why is it important is that if I start from the equator and say that my change in the latitude towards north, that is 50 degrees north, okay, then what will be my final position? Okay, from here I go from here 50 degrees north, so it has to be 50 degrees latitude, not latitude. Okay, now if I start from this point Bravo and I say that the change in latitude is 50 degrees south. Okay, I say that, okay, change in latitude along the same meridian, okay, 50 degrees south will be at equator. So this is the significance of CHLAT or the DLAT. Similarly, we can have the change in the longitude, but that also has to be measured in along a particular latitude. So if I say that the point alpha is at 50 degrees north, 10 minutes and the 15 seconds, and the point Bravo is 50 degrees north, 10 minutes and the 15 seconds. So they are in the same parallel of latitude. And let us assume that this particular meridian is, as we measure from the Greenwich meridian, it is 72 degrees, 30 minutes and 45 seconds. So we will say that the longitude is east 72, 30 and the 45 seconds. Likewise, the longitude of this place is 100, 30 and 45. So as we go from point alpha to point Bravo, I am slowly going towards the east. So therefore, the change in the longitude, which is the algebraic difference between this 100, 30, 45 and 72, 30, 45 is going to be 28 degrees. And in which direction it is changing? It is changing towards the east. So we will denote that this change of longitude or CHLONG or difference in longitude DLONG is 28 degrees east. Conversely, if I have to say express in terms of from B to alpha, it is 28 degree west. So now let us talk something more about more about these lines. Okay, so as I have shown in the diagram, this particular line is the equator and these lines are the meridians. Okay, if I zoom in here also, this is the equator, this particular line is the meridian, this particular line is the meridian. As all of you can visualize looking at this particular globe or in this particular diagram, all of them, that is the meridians and the equator, cuts at 90 degrees. So since these two lines cut at 90 degrees, so therefore this line or this meridian and this meridian and this meridian, all these meridians are parallel to each other. So there is no convergence in terms of angle between them. At equator, all the meridians are parallel to each other. So there is no convergence in their angle. But however, if we look at the poles, all these meridians are converging towards the pole. See, in the globe also, here in this diagram also, all of them are converging towards the pole. So exactly at the pole, all of them meet. All of them meet, isn't it? Isn't it? This inclination of these meridians, if I pick up this meridian, okay, this is 035 and the East 090 meridian, they are where parallel. See, if you look at this is the equator, okay, and this is the diameter, the circumference line, and this diameter has to be 90 degrees. This has to be 90 degrees. This has to be 90 degrees. So therefore, all of them were parallel at the equator. But however, as I keep going closer and closer to the North Pole, they started converging to each other. This particular inclination between the selected meridian, two pairs of meridian, okay, the inclination or the convergence between two meridian at the given latitude, okay, is known as the Earth convergence. We are talking about the Earth, okay, the Earth convergence, okay. And this, if you look at the equator, okay, it is change of the longitude, okay, here, and they are parallel to that. Okay, even if the change in the longitude is 45 degrees, there is no inclination, so the convergence is 0. But however, if we are at the poles here, okay, since the angle of inclination between them is 45 degrees, so we will say that angular inclination between these two meridians, that is 135 and 090, is 45 degrees. This 45 degrees is nothing but your Earth convergence. As we talk about this, at equator, it was 0. At pole which is 90 degrees removed, it is maximum, that is 0.45 or 45 degrees. So what kind of a trigonometrical function it follows? Nothing but the sine. Sine 0 is 0. Sine 90 is maximum 1. So we will say that the convergence or the earth convergence will be equal to the change of longitude, into the sine of that particular latitude, or in other terms, the sine of the mean lat. Now, I have talked about the convergence, the direction, but I need to talk about the distance between the 2 points. So when I want to measure the distance between the 2 points, there is a terminology which is known as the departure. Departure is the distance between 2 meridians. If we are talking about the same meridian, that is 090 and the 135 meridian, this distance, okay, this distance is known as the, at a given latitude, okay, at the given latitude is the departure. So this particular line is the equator. So therefore the length of this arc or the distance between these 2 points is known as the departure between these 2 meridian at equator. And if we want to talk about the distance, as we have discussed in my previous class, okay, the distance is measured in aviation in terms of nautical mile, and which is nothing but the length of the arc of 1 minute. So how many degrees are there? 45 degrees. And how many minutes make up a 4 degree? 60 minutes makes up a degree. So therefore 45 into 60 will be the distance between these 2 meridian at the equator, which is 60 into 45, 2700 nautical mile. But as you can appreciate in this diagram, as we go up north or south, what is happening? Because of the convergence, okay, the length of the arc is diminishing or reducing, and it will be finally 0 at poles. The maximum at the equator, 0 at the poles. What kind of a trigonometrical function? Maximum at 0 degrees, okay, and the minimum at pole, nothing but the cosine. Okay, so we will say that the departure will be equal to the CHLONG in minutes into the cosine of the particular latitude. So if we talk about this for this particular, if we assume that this is at 50 degrees north, 60, okay, in order to convert into minutes, into 45 degrees is a change in the longitude, okay, into cosine of 50 degrees, it will be 1735.526 nautical miles. So the distance between these 2 meridian at equator was 2700 nautical miles, whereas if we proceed either north or the south direction at 50 degrees north or south, okay, the distance between these 2 meridian will be 1735 point or decimal 526 nautical miles. This particular figure, okay, the 2700 or 735 decimal 526, this particular figure or the distance is nothing but what we said, the departure, okay, which will be finally 0 at the poles. After having discussed all this place as a kind of a practice, this particular table is a practice table for you. I have given you the compass heading here, deviation, magnetic heading or the magnetic direction, variation, and the true, okay, north. So the numeric is C is compass, D is deviation, M is magnetic direction, V is variation, and T is the true direction. So starting from the alphabetical order, C, D, M, V, T. So now this is 5 degree east, 10 degree west. I request you to calculate the compass north and the true north. Similarly, I request you to fill up the blanks. And also, as far as the departure is concerned, I have given you the question here. Calculate the departure between these 2 points and these 2 points. With this, I will wind up my class for today. Thank you. And if you want to check up your answer, you can forward the answers onto the comment box. Thank you, ladies and gentlemen. Have a nice day.